Now we're going to talk about stormwater detention. So our objectives are computing volumes by elevation area method. So we did that a little bit last week as an explanation, and we're going to review it again this week. Compute outflow for orifice and weir equations. So that's going to be new because that's going to be on our control structure and then reservoir routing. So those are the overall objectives. Now, when we're talking about stage storage control structures and the detention pond in general, so these are our ponds, and we talked about them last time. But in this sketch for our post-development class project, you can see these polylines. These polylines represent the elevation of the ground. So the lowest one is going to be our control, water elevation possibly, and then it's going to go uphill, 4 to 1. So the difference between that line and that line is 4 feet horizontally. But the vertical difference between it is a 1 foot contour. So it's the elevation change. So if you were looking at this, this water surface would be this last contour right here, this last line that's almost, I don't know if y'all can see it, it's shaded a little bit green. So, and the top here where it's kind of flat is, notice that there's a flat area in between, there's a space that's much different. So the distance between this line and that line is 4 feet. The difference between these two lines is usually 10 feet, sometimes 20. But normally top of bank is sloped at a 10 to 1. So the advantages of using the detention basin is it allows us to reduce the amount of flow off the site of a post-development discharge. Okay. The other reason you can use detention basins, there's other methods that you can use for detention, is underground storage, infiltration. So basically it just allows us to develop a site and reduce the flow off of that site. So we talked about developing the inflow hydrograph. So both for pre-development and post-development, we have to know both of those to figure out what size of structure that we have to build. Now, this stage storage curve, that means as water rises, there's volume in that pond that is being held in. So that's, the stage is the elevation and the storage is the volume number. Okay? So the last thing that we'll do is we'll actually create a curve for multi-stage outlets. And the reason we're doing all of this is because all the computer models are using that data to interpolate at certain stages how much water is actually coming out of it. So the purpose of it, like I said, is to release the water out. Now, here is our pond. So it is a retention or detention basin. We detain just by holding the water and releasing it. We retain if we hold all the water and let it infiltrate into the ground. There's a thing called permanent pool. You also, remember how I said last time is we can use control water elevation, surface water elevation, normal water elevation is another one, and anything below that water elevation that is continually held in the pond is called the permanent pool. And all these little dots is sediment and heavy metals or anything settling down to the bottom. So it has to be a certain depth to let all that pollution settle down to the bottom. So it has to be a certain depth. Anything from the water elevation to where the water is being discharged over some type of water quality treatment volume weir, then that will be how much treatment volume we have. We'll have a pipe that goes from our structure inside that box that goes to either a stream, a wetland, or a pond downstream of it, or even a pipe system or a ditch like in a roadway. Okay? Now, when we're talking about this, when somebody says attenuate, when you attenuate, I'm going to shift back a couple. Okay, when somebody says I need to attenuate, basically they're saying you're moving the peak to a different place. That means you're either holding it on site, you're reducing it down to a point that matches pre-development. That's attenuation. So the release rate and the timing is considered an attenuation. Okay. So store first flush. When a permitting agency says you have to store first flush, that first inch of rainfall, they're assuming, since we haven't had any rain here lately, do y'all hear on the news how many accidents we had on the roadways, like right after it rained. Do y'all know why? Because of all the oil that's on the street, people aren't recognizing, because everything that drips when you're standing at a stoplight drips on the road, and as you're traveling, all that oil that comes from your car gets onto the road. People are hitting that, and as soon as the water hits that oil that's on the road, it causes a slicker condition. Okay, that's a big part of it. I mean, that's not it exactly, but think about it. I mean, when all it is just, you know, sitting there, it doesn't really evaporate as much as water would, and it doesn't seep into the asphalt. So when we say store first flush, now imagine a rainfall event coming. Where does all that oil and whatever's on the road go? It gets washed down into the gutters on the side of the street, and then into the pipes into our pond. So that basically that first inch of rainfall that hits the ground is called first flush. So it gets all that sediment, pollution down into our ponds and settles. Okay? So when you're doing retention, you're designing for infiltration. So in Claremont, you don't see a lot of wet ponds. You know, you see grass in the bottom of the ponds. There's also, depending on the type of ponds or type of facilities that you're creating, that's another word. When somebody says it's a stormwater treatment facility, they're basically saying it's a pond, typically, or some type of structure or method of holding water. There's on-site and regional. Everybody typically has to do on-site. All new subdivisions that I'm aware of has to do ponds or something to hold the water to release it at a different rate, as long as your post-development is greater than your pre-development. Regionally, it's like I said with the locks and the dams, it goes all the way down to Okeechobee. So regionally, Okeechobee takes a lot of water. Okay, now it might not be a regional pond that's being collected, but that's what I mean. It's going to a point that is a much larger area than my little 5-acre pond needs to be. Okay. So the components that we need in a detention design is we need to get the water to the pond. So we have our inflow and our outflow hydrograph for our peak discharge. We have to, we have to determine the control water elevation. Now, what that elevation, I'm going to go back a picture. What that elevation in that pond is at is usually controlled by what the groundwater elevation is. If I'm near a wetland, I'm going to be controlled by the wetland stage. The reason we're controlled by wetlands is because wetlands are supposed to stay hydrated. They're supposed to keep their water. So if I had water, I'm going to draw another picture. If I had water, whoopsie. Here is, we'll just draw a little square site. Let's say this is our pond. Okay? And right next to the pond is a wetland. All right. Let's say the wetland, if I did a cross section through it, the wetland looks like this. And it holds water year-round at an elevation that's 71. We're just picking something, okay? Now, we'll say that there is maybe 50 feet between the wetland and the pond. If I made the water that's in this pond, if I did a cross-section, and it went slow, oops, let's use black just to keep consistent. Top of bank, 4-to-1 slopes, 2-to-1 slopes, okay? And we said the water is here is our control water. Let's say this elevation was 65. If the elevation here was 71 and the water elevation here was 65, that's 6 feet elevation difference, right? Natural gravity in the ground, where do you think the water from this wetland is going to go? It's going to go to the pond, and we don't want that because it's actually sucking water. I mean, that's not a technical term. It's actually pulling the water from the wetland into the pond. And jurisdictions, the water management districts, will not allow that. So typically, if we're that close, you're going to say that control is at least at a 71. So you're not pulling water to the pond. So that would be how our control would be set. Now, how to figure out where the water is or the normal pool in a wetland is going to be an environmentalist job usually. They say that there's markers on trees, high water levels. Let's say that's not a wetland, that's just natural ground. So what a soils person would, a geotechnical engineer would do, they would go out and they would do borings into the ground, and they would say, okay, where was the groundwater located? So if you did this soil column, let's say I, took a core sample or a boring, sad boring. So this is ground, and I did a boring, huge deep boring in the ground, maybe 10 feet deep. And the reason they're going 10 feet isn't because of the groundwater, not here in Florida. They're going 10 feet to see how good the dirt is that they can use on the site for fill. So that's why they go 10 feet down. They want to know what that depth is. But let's say the groundwater, and again, this is the symbol normally used for some type of water. Let's say it's 2 feet below the ground, and natural ground was at a, let's do math easy today, at a 70. So the groundwater elevation would be at a 68. But here's the thing. There's a thing called seasonal high water table. And I'm telling you a lot of things that aren't technically in textbooks, but these are the types of things that you have to know when you start getting, working in the industry and permitting with these agencies. There's another thing called seasonal high water table. Seasonal high water table. That means we know we get our summer rains, right? So the summer rains actually comes up, and then when they pull these samples, they actually can see in the columns of the soils how water may fluctuate. Okay, there's some type of indication that normally it's only 1 feet. So now the seasonal high water table is a 69. So the lowest we can actually put our control water elevation, our normal pool, our surface water, is at a 69. That's what we're controlled by. That's the first thing you have to figure out when we start designing ponds, because that's where the orifice is going. So if I'm looking at this structure here, and your orifice doesn't always have to be circular. It could be a V-notch orifice. I've actually done rectangular. They're not orifices, but that's the bottom. See how water is stuck right here? Let's just say that bottom is the control. All right? So these objects here are weirs. Okay? Orifices are usually just circular or V-notch, and weirs are broad-crested or rectangular or something like that you're seeing here. Now, there's also an emergency spillway. When you have, here on Valencia, if you look over on the parking lot next to us, there's 2 big retention ponds that basically they hold water, but they're not always full of water. So at the top of it, you'll see a broad-crested weir. Let me see if I can go to Google Earth for the guys that aren't in class that can know what I'm talking about. Well, that's coming up. Usually you have emergency spillways when you're working on projects that are retention. Because they don't have a control structure, they usually use an emergency spillway. 1800 South Kirkman Road, Orlando. That's where we're at here at Valencia. I love Google Earth. I mean, you could do a site visit in a heartbeat. Okay, so we're in, right here. We're in this building over here. And see this part right here? That's the overflow weir. So all the water that doesn't go to either Lake Pamela here gets diverted, and you can actually see right here, here, and over here, if you zoom in, there are actual mitered end sections. These are mitered end sections. So water discharges into this area here. And it's a big, you can almost see it as it goes downhill, flat, back uphill in the parking lot. So water fills up on this side and then spills over the top of it. Okay, I think this is about 15, maybe 20 feet wide, and this length here is about the same, maybe about 15, 20 feet wide, maybe a little bit bigger. My proportion is a bit off. All right, so let's go back to our PowerPoint. As soon as I find my PowerPoint. All right, so those are the concepts. The next part that I'll go over is some more of the permitting requirements and what detention ponds look